Hey, what is going on, guys, and welcome to another video as we continue with our Python Programming Massive Open Online course by the University of Helsinki. In the previous video, we finished all the exercises and reading of section 2 of part 2 on more conditionals. And in this video, we're gonna start and hopefully get through section 3 of part 2. All solutions from the previous video and all of part 2 that we've done so far are up on the GitHub repository. So you can go ahead and take a look at them if you haven't done them, or if you just want to compare notes. The link to the repository will be in the description below. If you do visit the repository, please give it a star. I truly appreciate it. Just lets me know that more people are find this useful as a source of material and a source of having material to learn from. So we're gonna do section 3. We're going to start section 3 again, like I said before. Hopefully we get through it. If you have any questions, please leave them in the comments below. And as I've done in the past, if there's anything that I think of while I'm reading the material that I've learned from years of experience or from when I was in college or just good things to know, I will talk about them. But I will try to refer to the material as much as possible, but if there's something missing or I feel like something should be important that should be covered, I will definitely go on a tangent about that as I've done in the previous videos. So let's get started. Here we're going to be learning about combining conditions. And the learning objectives for this section are as follows. It says after this section, you will know how to use operators and, or, and not in conditions. And you'll be able to write nested conditionals. So these we're going to learn pretty immediately in the material. This is referring to being able to nest if statements within each other. So far we've only learned how to write if statements like this. If number is greater than or equal to 5 and number is less than 8, then do something else, right? But you are also able to nest one condition inside another condition. So it could be an if statement here, and then inside of it will be another if statement, and then you can tell it the program to do something. All right, so let's get started. Logical operators. You can combine conditions with the logical operators and, or. The operator and specify that all the given conditions must be true at the same time. The operator or specifies that at least one of the given conditions must be true. For example, the condition number is greater than or equal to 5 and number is less than or equal to 8 determines that number must simultaneously be at least 5 and at most 8. That is, it must be between 5 and 8. It must be 5 and 8 inclusively. I should clarify that. So this condition, whatever the number is, it can be 5, 6, 7, and 8. It could be either one of those. So if it's less than or equal to 5, number could be 5 and this condition will be true. And the number could be 8 and this condition will still be true. So here we have a little code block. We have a variable called number, which stores the integer value that the user provides of a number. And then we have a conditional here. If number is greater than or equal to 5 and number is less than or equal to 8, print the number is between 5 and 8. So so one thing that I've noticed in some of the previous readings is that whenever they have these code blocks, I tend to have to explain how the code will evaluate. Sometimes it will have a code block, a text block beneath a code block like this, and they will explain what the code will do when the code is running. But I think it will be very cool if we could use a Python IDE, an online IDE, to be able to run this code ourselves and see what we'll do if we give it different values. So here I have this online IDE.pro/playground/Python, and they have a Python playground here that you can use to just write some Python code and run it very quickly and see what it does. So here we have the code block from the reading material. Again, we have a variable called number. It stores an integer value that we provide. And then we check if number is greater than or equal to 5 and number is less than or equal to 8, then we print that the number is between 5 and 8. So let's run this code and see what happens. We prompted, please type in a number. If I write 6, it says the number is between 5 and 8 because 5 6 is greater than or equal to 5, and 6 is less than or equal to 8. Now, as I mentioned, that this conditional is inclusive, meaning it includes 5 and it includes 8. Meaning, if we provide 5 as a number, this print statement will go through. And if we provide 8 as a number, it will also go through. So let's see that in action. So please type in a number. We provide 5 and it runs. And if we provide 8, it runs. But if we provide 4, for example, we don't get this print statement. And if we provide 9, we also don't get that print statement. Again, so when you have less than or equal to a number or some condition, it means that this lower threshold of that conditional is included. So it's also a possible solution, basically. Same thing as on the higher end, it's also a possible solution. So that's what the code does when you run it. I would have liked if they would have explained it here a little bit, but they didn't. But yeah, when you have less than or equal to, it means that it's inclusive. Now, this is pretty common knowledge if you have experience in programming before or if you're a math head, but that's basically what this means. So 5 and 8 are also possible solutions. It doesn't have to just be 6 and 7 as the possible answers. Now here we have another one. It says, meanwhile, the condition number is less than 5 or number is greater than 8 determines that number must be either less than 5 or greater than 8. That is, it must be within the range of 5 to 8. So now this is the OR condition, meaning either one of these has to be true, not both. When we do AND, the left-hand side of the logical operator has to be true, and the right side has to be true. When you do OR, either one can be true. So if this one evaluates to true, then we automatically go here. We don't even have to check this side. But if this doesn't, then we go and check this side. If this side is true, then it prints this statement. Otherwise, the code will just exit. So let's plug that in over here, and let's run it. So it says number can be less than 5 or number can be greater than 8. So if we plug in 6, this is not going to work because it's within 5 and 8. But if we plug in 4, then this works, right? So we don't even have to check if number is greater than 8. 4 is less than 5, yes, go ahead and print that statement out. Same thing, if we plug in 9, then it prints the numbers now within that range of 5 to 8. So this also works. So we checked number 9 is not less than 5, right? 9 is greater than 5. Then we come and check on this side. Is 9 greater than 8? It is, so we print this statement out. So here we have a truth table. It says the following truth table contains the behavior of these operators in different situations. So if A is false and B is false, then A and B evaluates to false because both values are false. But if it's OR, it's also false, right? Because there's nothing that's going to trigger the truth condition. If both conditions are false, so our code will go, is A false or is B, is A true or is B true? Well, A is false and B is also false, so it's just going to return false. Here we have A is true, B is false. Again, when we use the AND logical operator, both sides have to be true. So A is true and B is false. It's going to return false because both conditions have to be true. But if A or B, as long as one of them is true, then it's going to return true. Here we have A is false, B is true. Again, for the AND operator, it's going to return false because A is false and B is true. Both sides of the AND operator have to be true in order for it to return true, so it's going to return us false. But here again, similar to this row, because we have one true value, it returns true. So A is false, but B is true, so it returns true. And down here we have both are true. A is true, B is true. So again, for the AND logical operator, because both values are true, it returns true. And because either one of them could be true with the OR logical operator, it returns true. Sometimes it is necessary to know if something is not true. The operator not negates a condition. So if A is true, then not A is false. So it's basically flipping what the set value is. And then if what the intended evaluation will be. And in this section, if A is false, then not A is true. It says the above example with the range of 5 to 8 excluded could also be programmed like this. Number, integer, so we have a variable number, it stores an integer value, and then we say if not, number is greater than or equal to 5 and number is greater than 8, then print the number is not within the range of 5 to 8. Meaning, if we put 5, 6, 7, or 8, then this will be true, right? If you remember up here. Let me copy this again. Go to our playground, paste it. So we say here, if number is greater than or equal to 5 and number is less than or equal to 8, then the number is between 5 and 8. Meaning, if number is 5, 6, 7, or 8, then this will be valid to be true. But if we wrap this in parentheses and precede it with the not operator, then this will evaluate to true if we put 5, 6, 7, or 8. But if we do not, then it's going to give us false. So that printed number is not within the range of 5 to 8. So let's see this in action. So if we wrap this in parentheses, put not here, and then we run. So if we plug in 5, it's not going to return anything, right? Because we wanted to, essentially what we're saying here is whatever, when this evaluates to true, flip it. Bring back not true. So how would this condition give us, will give us this? In fact, you know what I should do here? Then I'll say else. Print that. I'll move this up and move this down so you can see what I mean. So if I plug in 5 here, it's going to print our else statement, right? The number is between 5 and 8 because this condition, what's inside this parentheses, evaluated to true, but we said if this is, right, give us an answer if it's not true. So it skips this and goes straight to printing this. Now watch what happens if I plug in 4, for example. Then we get the numbers not within the range of 5 to 8. So I like this example more than what they provided here because you can better see it in action as to what's causing this to trigger. Basically, like I said before when we were looking at the truth table, with the AND logical operator, both sides of this conditional have to be true. And then we're telling Python, whatever, if it is true, flip it, bring us false. And then this is what prints. So basically, if this is false, that's exactly what we're saying. I think that's an easier way for me to say it. We're basically saying, if this is false, then print this. Otherwise, don't do anything. But it's easier to see it working when you have an else statement here telling us what should be printed if it's false. So we're saying, if this evaluates to false, then say that the number is not within the range of 5 to 8. But if otherwise, which would mean that this does evaluate to true, then print this. So when we plug in 4, this falsity becomes, this is one of those things about logical operators and conditionals that's like, it kind of is like a mind-bending thing to think about. But hopefully I've explained this pretty clearly. If you're still having trouble with this, let me know in the comments and I'll make another video just talking a little bit more about it. But that's, hopefully I've gotten the idea down. I've conveyed the idea down pretty well. Again, we're saying so basically if this is true, then do not true. And then print that. Otherwise, print that it's true. I think this is an easier way to see it working. All right, so let's continue. Especially in programming, logical operators are often called Boolean operators. Yes, because they always return true or false values. Or they evaluate a condition, and if that condition is met, then they do something. So, Boolean values. Simplified combined conditions. This is one of those side notes that they provide. It says the condition x is greater than or equal to a and x is less than or equal to b is a very common way of checking whether the number x falls within the range of a to b. Again, inclusively. It includes a and b. An expression with this structure works the same way in most programming languages. Python also allows a simplified notation for combining conditions. So if a is less than or equal to x and less than or equal to b, achieves the same result as the longer version using and. This shorter notation might be more familiar with mathematics, but it is not very widely used in Python programming or programming in general, just because the notation is a little bit harder to read. And like remember I said in the earlier videos, writing self-documenting code or code that's easier to read makes it easier to debug. especially when you're working on a project with a big team and that team has varying experiences. Somebody might be used to writing programs in shorthand and somebody might not be. So you want to write code that, you know, anybody, depending on their experience, can still be able to read it and make sense of what's going on. This short notation might be more familiar from mathematics, but is not very widely used in Python programming, possibly because very few programming languages have similar shorthand. I think Java might, but I'm not sure. I don't remember exactly, but I think Java might have, or C++. But anyways, let's continue. Combining and chaining conditions. The following program asks the user to type in 4 numbers. It then works out which of the 4 is the greatest with the help of some conditions. So we have 4 variables here, n1, n2, n3, and 4. All 4 variables store an integer that we provide. And then we check if n1 is greater than n2 and n1 is greater than n3 and n1 is greater than n4, then we say the greatest equals n1. Else if n2 is greater than n3 and n2 is greater than n4, then we say greatest is n2. Else if n3 is greater than n4, then the greatest is n3, and then otherwise n4 is the greatest. So we check if n1 is greater than the rest here, then n1 is the greatest. Then we check for n2. Now you're probably wondering why are we not checking if n2 is greater than n1 first? Well, because we know that if n1 is greater than all of them, then that means n1 is greater, right? So it doesn't matter if we check n2 is greater than n1. As long as we know that n2 will be, in this condition, we're assuming that n2 is going to be greater than n1. Because if it isn't, then we know that n2 isn't greater. But we've already evaluated here that n2 is not, if n1 is greater than n2. So that's why we're not checking if n2 is greater than n1 over here. Then again, n3 is greater than n4. We say n3 is the greatest and n4 is the greatest if all these other conditions are not met. Then we print greatest is the greatest of the numbers. All right. So here, this is how the program will be evaluated, and this is what I was talking about earlier when we were reading this part. Sometimes they put beneath some code blocks, how it would look if we were to run the code. So here, n1, we plug in 2, n2, we plug in 4, n3, we plug in 1, and n4, we plug in 1. And in here, the value is that 4 is the greatest of the numbers. It says in the above example, the first condition, n1 is greater than n2, and n1 is greater than n3, and n1 is greater than n4 is true only if all 3 conditions within are true. Okay, so I'm going to stop here in regards to the reading material. Actually, let's just talk about this a little bit. And again, that's why, because we chained and 3 times here, twice, then that means that when we're using the AND operator, then all sides of the conditions must be true. So this has to be true, this has to be true, and this has to be true in order for greatest to be assigned the value of n1. Same thing here, n2 greater than n3 and n2 is greater than n4. Both this side has to be true and this side has to be true for n2 to become the greatest value. Here we just check if n3 is greater than n4. We don't need to check anything else because if that means n1 is already great, so we'll never even get down here. Basically what this code is saying. If this is true, then we don't need to worry about the rest of this. If this is true, then we don't need to worry about the rest of this. If this is true, then we don't have to worry about this. Otherwise, this is what the last one will do. So that's what this is referencing. So I'm going to stop this video here. And in the next video, we're going to start doing these exercises. So we have, so we have 3 exercises. So I think the next video will just be these 4 exercises. And then the video after that will be us going through the rest of the materials and also doing the remaining exercises because it's only a short reading left. So that's how I'm going to break down this section. So I will see you in the next video where we go through these exercises in detail.